Hi, welcome to an Arduino step-by-step course by Robojax. In this tutorial, I'm going to show you how we can use this L298N motor controller module to control DC motors with push buttons. For example, for this motor, I have counterclockwise and clockwise push button and also start and stop. If I press this, the motor will start rotating. And if I press this, the motor will start in different direction, or I can stop it. So you can change the direction clockwise and counterclockwise, and also start or stop. You can control two motors with this module. I have a separate video explaining this module. I have written a library for this that you can use this to control DC motor very easily. Make sure to watch that video and make sure that you are able to control two DC motors without any push button or any other component, just directly connected. So it will be very easy for you to continue in this tutorial. Otherwise, you will have a lot of issues. There are instances that you need to control a DC motor. For example, to press a push button and the motor will start rotating. And then you need to press the stop button to stop it. And also there is another push button that you need to change the direction from clockwise to counterclockwise and vice versa. So this code is for that applications, and for some other purpose also you can just manipulate and change the code. Instead of push button, you can control the motor with some kind of signal sensor or external parameters as well. Let me explain the wiring. For this module, this is my battery wire where I connect my battery, and the positive will be connected at this point. You can connect from 6 to 35 volts. If you're using 5 volts, connect 5 or 6 volts, because there will be a little voltage drop here. So depending on your motor voltage, connected. If you have 24 volts motor, connect 24 volts. If you have 35 volts, up to 35 volts can be connected in here. And the second wire is here, ground. From this point, I have this gray wire which is connected to Arduino. You need to connect a common ground between the modules. And the last pin is output of 5 volts. I've explained this in my separate video. So the 5 volts come from here, and you will supply 5 volts to Arduino by connecting it at this pin. You will connect it only if the USB is not connected. When you program it and the power is here, make sure to disconnect it so the current does not flow between the two devices. And here for the push button, this is for clockwise and counterclockwise control, and this is for stop and start. And I'm using this long type push button with a long pins, which I've purchased from eBay. This side is connected using this wire to this blue line. This is my ground, and from here also I've connected this to the ground. From this point I have 3 wires. Like this. Orange is connected to the left pin of this switch, and then red is connected to the left of stop, and from this point this is ground. I've connected the ground here to ground of Arduino at this point, and then for the right push button, the orange is connected to pin 8, and then for the left or start the stop push button, the red is connected to pin 9. And here for motor 1 we are using 3 pins, and these 3 pins will be used for motor 2. This is enable A, ENA, and ENA is pulse modulation enable pin. It is connected to pin 3, which has pulse modulation tilde. As you can see, 5, 6 also has a tilde, 9, 10, and 11. The rest are not, and make sure you will connect this enable A to a pin that is pulse modulation enabled. Input 1 is connected to pin 2 using gray wire, and input 2 is connected using white wire to pin 4. And here is the wiring for the second motor. This is for clockwise and counterclockwise for the second motor. This is for the start and stop of the second motor. the same way as before. The right side is connected to the ground. This is my ground, which I have already connected. Only this one for the actual switch, green, is connected to pin 10 for this clockwise counterclockwise, and for the stop using blue it has been connected to pin 11. And here for the data, this is N3, this is N4, and that's enable B. I've connected accordingly in reverse. Enable B is connected to pin 5 because this is pulse width modulation, and the next pin is green. This is connected to pin 6, input 4, and input 3 is blue. That has been connected to pin 7. My second motor is connected at this point on this side. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. Let me explain the code now. As I've explained, you have to download and install the library. Watch the introduction video. This line says include Robojax L298N DC motor. This is the library that I have written, and it will be included because it is needed. And we are defining N1, pin 2 as N1, pin 4 for N2, and pin 3 for enable A. Any pin that has this tilde, it means pulse width modulation enabled pin, and you must have pulse width modulation enabled pin for this. And we are defining CCW as a number 2 and CW as 1, and motor 1 as 1, motor 2 as 2. Do not change these will be used internally. And here this is a constant integer push button delay time. This is the time that when you press a push button, it takes a while before you lift your pen up, your finger up, or when you press it, you need some time. So this time is experimentally determined that it will work for me. You can change it, either reduce it, make it smaller value, or which means it will be faster, or increase it until you find the right value. This portion, it says all for motor 1, and we are defining an integer motor speed. Because we cannot change the value of the speed of a motor, you can permanently set some value here in the code, either whatever value in percent. So this 60 means 60% of the speed. If you want it full speed, just make it 100, and some value in between if you wish otherwise. Constant integer motor 1 push button direction. This is a direction push button. I have defined pin 8, and then this is a stop push button, defined pin 9. And because motors need some initial value, pulse width modulation value, to make it start moving, so you can either set it to 0 or set it to certain value. And direction of motor 1, we put some value. Do not change this. This will immediately change when you push the button, but we have some value when the program works. Always this will be updated as CCW or CW. And then the motor start stop state. This is holding the push button for the start and stop, and this is also for initial value. If you want the motor to be stopped, this high means a stop, and if you wanted the motor to run as soon as Arduino starts, then set this to low. This line we are creating from the class from library. We are creating an object, we call it motor, and we pass this N1, N2, and enable A pin values to this class so it can set it up. And if you want the comment, the debugging information, for example, if I open the serial monitor, these values are printed because we have here true. If you remove this like this, the debugging information will not be displayed. So you will initially have it. Once everything works fine, remove it, and then because it will use some resources, so to eliminate that. This is for the second motor, which I will explain later. Inside the setup, we initialize the serial monitor with serial.begin with 115,200 baud per second, and this line means motor.begin. We are using that object. .begin is a method or the function belong to this object, and it uses all those values and other parameters to set up the library for the motor. And this line, pin mode, we are using this line to define a motor 1 push button for the direction and also for the stop to initialize the input pin for the input. And here I have used input underscore pull up This pull-up refers to setting the input pin as a pull-up internally, so you don't need to use a resistor. Otherwise you have to use a resistor if you use it like this as an input. So I have separate video explaining that. The link will be below the video in the description. Inside the loop, update state 1. This is updating the state of motor 1 for the push buttons, and which I will explain next. And here we check if motor stop state. If it is high, this two equal mean compare this value with high, which means stop have been requested. Then motor dot break motor 1, so motor 1 will break. Else means so motor is running, then we say motor dot rotate, and we pass 3 parameters. You see I've been separated with 2 commas, so we have 3 values. The first value is motor 1, which motor, and this motor 1 is speed, and motor 1 direction, clockwise or counterclockwise. And this line is commented, but if you want to check your motors, just uncomment this, and then if you put 2, motor 2 will be tested. If you run 1, motor 1 will be tested with different parameters, clockwise, counterclockwise, with different speeds. And this is another example in case if you want to use it or need it. And this is the delay push button delay time that we have defined above for the push button. And every time the loop runs, this delay will give enough time for the push button to be pressed or released. And this is the end of the loop, and it will continuously takes the same action. Now, update state is a function that I said I will explain it. Now, every time the loop runs, first this will run, and let's check what it does. Update state is a function that does not return anything. It says void, and we use digital read. Motor 1 push button direction, we read the push button, and this is a value. Every time we push it, it is set, the value will be low, and if you don't push it, because we used input pull up, it is up or high or 5 volts. That's why when you push it, it will be low. So we check if it is equal low, which means the push button is pressed. Now we have to toggle or change the direction, and now here we check if motor direction is equal, this means compare it and see if it is CW, then set motor direction to CW. You see here we have one equal sign. This is for comparing, and this is for assigning. So this value is assigned to this, and we also parent this. And if it else means if it is not CW, then it is CCW. Now we change it. We put CW to this value. We change the value, so this will change the direction. And then also in the same time we check the stop push button. This value will check if it is low, which means stop have been requested or pushed, start or stop. This time we do differently. We let's say if the motor was in stop, if it was low, what we do is this value will be low, so 1 is high and low is 0, so 1 minus 0 will be 1. So the value for this calculation will be 1, will be stored here, which means the value have been updated. If it was 1, let's say if this was 1, 1 minus 1 will be 0, and we will store the 0 in this variable, and the start stop value has changed. This is a demonstration of controlling single motor. I will do the 2 motors together next. I've connected my battery here, the power is on, and also this USB is not connected. I've connected the power 5 volts from this module to this point, and I will open the serial monitor so you can see. Now I'm holding it, so now it shows 60% CCW. If I press this, it goes to CW. I can stop it, start. Now remember, this was CCW. If I press this, the direction has already changed. But if I run it now, you will see that it goes as CCW, because this switch, this push button works regardless if this start and stop is running. This will change the status, and then when you stop or start, you will see the effect. Now let me demonstrate you controlling two motors. I will open the serial monitor as well so you can see it. Right now it shows motor 1, motor 2. They're all braked, so they're not moving. And now if I press this, this is for controlling motor 2, stop and start, and this is clockwise, counterclockwise, and this is for motor 1, clockwise and counterclockwise. I will press this and hold the motor so they don't move. Now this motor is moving. And I can change the direction. As you can see also it shows here. I can stop it. And now let's go for this. This is running. It shows motor 1. And now the direction changed. Now let's turn this on as well. Both of these are now running at CCW. One is CW and one is CCW. My switch was not properly connected. It's very loose, but the reason for the 60% speed is that I've set the speed here. This is the speed that I've set. You can change it. This is a 60%. If you want your motor to run at 100%, you can make it 100. Thank you for watching. This was how to use this L298N module to control DC motor with 2 push buttons. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. Thank you for watching the tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos.